Now, our final morning speaker is Anna Konopitskaya. She and Drew run a research farm on the other side of the state. She's an architect, and they have a lot of products to show us as well, too. So I really want to hear from Anna about all of the work that she and Drew have been doing to explore this in many different ways. So let's hear from Anna.
Good morning. It's a pleasure to be here. And Leslie, great event. Thank you very much. Happy to be here. Okay, so my name is Anna Konopitskaya. I'm one of the co-founders of Coexist. The other co is right there, Drew Oberholzer, another co-founder. So what do? I will start with our background just to give you an idea of where we come from, why we do this. Leslie at the beginning said, why hemp, why now? Those are the two questions that we absolutely ask ourselves every single day, especially as product manufacturers, because if we can't answer that question, then how can we ever convince anybody to buy the product or make a difference and incorporate that material into our built environment? So as Leslie mentioned, I'm an architect. So I worked on all kinds of different projects, different scales. The smallest one was probably the Jim Henson exhibit at the Museum of the Moving Image. Larger was some universities, institutional projects. Larger condo buildings in New York. This is in Manhattan. Even bigger condo buildings. We combined the two buildings there, turned them into condos, put the penthouse on top. Even bigger Museum of the World War II Museum in New Orleans. And if you thought that there is nothing bigger, there is something bigger, and that is the airport. So that was my last project. And with every larger project, I thought, we're putting so many materials into this. And then all of that we're replacing goes into the landfills. So at the airport in particular, they do the renovations about every 5 to 10 years. So every 5 to 10 years, they strip what's there, put it in a landfill, and fill the space with something similar or even worse, because our progress sometimes, unfortunately, pushes for things that are cheaper and worse in quality. And so that was in LA, and when we lived in LA, I thought, okay, there has to be some kind of alternative, something else better that we can incorporate. And so we started looking around, and we couldn't find really anything. And that's California. California, not everybody shares this opinion, but California is very progressive. But even there, we couldn't find anything. One company was selling styrofoam insulation that came from Scandinavia. And we thought, how is this green or progressive? This is crazy. And then we started looking at Europe, and hemp was going full speed, and the industry was growing. And we thought, okay, it's illegal here, but maybe we can start looking into this. So we started looking into this about a year before it was legalized. Before it was legalized, we jumped off the cliff, so to say. We bought a farm in Pennsylvania, moved here in anticipation that it would be passed, and it did. And so now we experiment with raw material. We grow our own hemp to see what varieties do well. We work with industry partners, with universities, with testing facilities to work with hempcrete. We also develop hemp-based plastic material. We experiment with other things for building industry. And so that's one aspect of what we do. When we developed our block, we are the first company in the US to find a way to mass produce the block. And we manufactured at a facility in Reading, Pennsylvania. And to market it, we were speaking at the events like this, but we felt like it wasn't enough. We had to do something else. So with my background, we decided to, well, what if we design a little building, like a little office that people can put in the backyard? Actually, that was during COVID, when we ourselves desperately needed a space outside of our home, just a little separation from home. And so we designed that, and the idea is that a homeowner can have it shipped to them, and they can assemble it within about 2 weeks themselves without the need of a contractor. Basically, it comes with instructions and everything. And the idea is that we will market that with a hemp insulation in it. And so that's what we kind of spent time doing. Sorry, how do I go back? Oh, right. Oh, okay. So basically we developed this model. We had it built in partnership with the university here, Alvernia University. We're selling them now. We pre-sold several units. Right now, one of them is being built just with hemp, no cedar facade, and then 3 more will be coming in upstate New York. So very excited about that. And so we've been recognized for our design work and our manufacturing and all that. So currently, if anybody is going to be in Venice in the next week, please stop by. Our exhibit is there at the Venice Architectural Biennale, which is the very prestigious event in the architecture world. We were invited by the Cultural Center of Italy to participate. So it's there now. And then on the right, we have different publications that we published. And so definitely there is interest in the world for hemp, and we're definitely trying to explore that to basically not reinvent, but offer an alternative in the built environment, something that hasn't been done in about 70 years in the US. Okay, so why now is the question less. Why now is exactly what we ask ourselves all the time. One of the reasons why we got into it originally is because the sick building syndrome, we all heard about this. What is it? It's when some buildings, some materials off-gas and others entrap it inside. Because our building wrap kind of keeps it inside, and we get everything engineered. Our furniture has formaldehyde in it. Our fabrics are synthetic, and so on and so forth. Okay, we spend so much time indoors, so this is crucial. But my particular presentation for today actually is going to focus on something else, and that is, as Michael pointed out, let me just took a note there. Okay, people, plant, and profit. So it's very important to understand that unless we are able to market it to people, unless they're interested in the project, in making that change, and we don't want to force anybody, there's really no alternative. There is no business, because if we don't have profit, there's no business for us. Anyway, so we talked about mold, that it doesn't grow mold, and people would say that's just wonderful, but that's in 10 years. And we would say, well, there are health benefits. It purifies the air. People would say that's wonderful, but that's in 30 years. I'll see some kind of benefits. What about now? And so it was always surprising to us that it seemed like we couldn't, there was no point in hemp that we could kind of justify, or for people it would make sense to justify slightly higher costs, even those things like it doesn't grow mold. And then the carbon issue kind of became the centerpiece of our news and our climate change and all that. And it's a terrible thing that's happening, but it all comes together. People hear it more, people understand we need to make a difference. But carbon emissions are directly tied to energy consumption. And so when we tell people that if you use less energy, your bills will go down, people say, oh, I knew there was something in this hempcrete. So what I wanted to mention on this page is, okay, so United Nations comes out with this report every year, where they publish the, how bad it's getting, and, the snowball effect and all that. And if we don't stop now, we're all gonna have limited opportunities in this life for our children. And anyway, so interesting fact, New York City, the size of New York City is added every month across the planet. And it will be added for the next 40 years. So it's huge. What does it tell us? That building industry is a great opportunity to make a change. Okay, second thing, I'm gonna use a laser. Okay, so this pizza diagram here comes from the same report, and it's been quoted over and over and over in so many places. And people say 40% of carbon emissions come through construction industry. And what they there's actually a lot more than 40% that are responsible for our carbon emissions in the construction industry. It's a lot more. It's probably over 50, because here they're looking at so concrete, steel, and aluminum for structure and so on and so forth, concrete and operations, but their finishes are all these things that also go inside of the space. And maybe it's not that important. It's on a smaller scale, but it all contributes to our carbon emissions. And exactly what kind of carbon emissions are there? There are two types. One is operational and one is embodied. And so embodied is everything you need, is the energy you need to manufacture building materials. And operational is what you need, the energy you need to maintain optimal conditions in the space. So heating, cooling, basically. And so if you want to make a difference, we have a choice. We can either modify how much energy we use to produce the product, or we make a seal the envelope better so that we spend less energy on heating and cooling. And of course, the best option is if you utilize both or affect both. Okay. This block literally can replace all these materials on the right. So foam, vinyl siding, wrap, drywall, fiberglass insulation, and then spray foam, which is one of the worst things you can do. It off gases for the rest of your life in the building, just so you know. Okay, they use it for window insulations as well. We can't get away from that because part of the warranty, but it's one of the worst stuff. Anyway, so hemp block can actually replace all of this. And what does that tell us also? We also can lower our reliance on the crude oils. So, which is something we definitely should look into in the future because it's running out. Anyway, so that's a wonderful thing. No one talks about this. Those are parts of standard assembly in the buildings. It practically goes into every single building, but we can replace it with this. So two things I talked about, operational carbon and embodied carbon. So you saw all kinds of applications of hempcrete, but I will talk about block specifically. There's a question about retrofitting. So, or using it on a more traditional construction. If you use it on the inside of the assembly, so facing your interior space in the house, what it does is it actually can, so the block, I will start with that. The block has a thermal mass property. Usually it's some masonry units that have a thermal mass property. What that means is that it absorbs the heat during the day and releases it, which one? Yeah, absorbs the heat at day and releases it at night. So basically, if you're too hot in the house, you open the windows in the middle of the winter to air out the space, something people do in Europe all the time. You don't need to worry about losing the heat that you just accumulated because your blocks are going to continue to emit that warmth into the house. So that's sustainable, that's good. Also what it does is it helps you to eliminate thermal bridge. Thermal bridge, it happens when you take an element in your wall assembly and that element connects indoor to the outdoor. So some people, some builders used to build houses, and actually even now, they use this product called T111. It's a wood fiber board, it's like OSB that they used to put on the exterior. Now they used to do it on sheds. It's a very popular shed product, but some houses are built the same way. So basically that OSB is directly attached to the studs, and your stud on the interior is faced with the drywall. So basically your stud transmits a temperature from exterior to interior, and that increases your energy bills. That's a terrible practice. Anyway, so that's called thermal bridging. So with this here assembly, the block kind of eliminates the thermal bridge, and it will lower the energy costs for the homeowner if placed on the inside. But another thing with this assembly is this. So we stopped using foam on exterior. What you see here is a wood fiber board that's impregnated with wax. So there's no formaldehyde. Formaldehyde is glue. There's no formaldehyde in that board. It's actually pressed with wax, and which also makes it water repellent. It's a very popular product in Germany, but fortunately now we have GoLogic company in Maine that manufactures it. So we can actually source it locally. But we did import it from Germany before. Excellent product, replaces your foam on exterior. So if you use that product on exterior, that also stops the thermal bridge. So also a lot of building codes now, the modern building codes recently passed, require the continuous installation on the exterior. So if you place it on the exterior and you place the block on the interior, the thing about the block too, we're exploring this option. It has to be still verified with the building code, but because it's a masonry unit, it actually does not have to follow the same arc value requirement as the batt insulation. This is crucial because for your batt insulation, you need R19 in Pennsylvania. With a masonry unit, you need R13. So R13 means thinner piece of hempcrete, Also, if you use that insulation on exterior, what that means is you don't need a bad insulation in between the studs. What that also means is that currently, if we need R19, our studs need to be 2x6. But if we don't need that insulation, then it's 2x4. It's cheaper, and also airspace, if it's sealed properly, becomes an excellent insulator in its own. So this assembly actually is a great alternative. It's cheaper to build it this way. However, there's a nuance. Hempcrete is more expensive as any other building material. So hopefully this kind of idea can neutralize the extra cost. So by doing that right now, we can kind of bring the cost down of that construction. So that's a thought. And then, so basically placing it on interior with where it uses different aspect of its insulation properties, and lower R value, requirement, will bring your cost down of the construction. Now, if you place it on exterior and replace the foam on exterior, basically it does a lot of things too. So it eliminates thermal bridge, let's see. So it replaces rigid foam, prevents thermal bridge, lowers energy bills for the homeowner, and lowers the carbon footprint. And so basically in this case here, if you replace the most offensive product that contributes the most to the carbon emissions, this assembly will be more environmentally friendly, while the other one will save more money for the homeowner. Okay. Just to summarize the benefits of hempcrete, we use no chemicals in production of the blocks, no chemicals to grow it. It's termite and mold resistant, flame resistant, excellent insulation, helps you control moisture in the space. So prefabricated grass base, we've already gone over that. Okay, so this lecture today right now is about insulation as a building product, because this is a great piece of construction that we can substitute and contribute greatly to lowering the carbon emissions. And so if you look at extruded polystyrene foam, it's the worst offender there. The best you can use is straw bale, but not everybody likes straw bale. So hempcrete is the next best option there. And because it's fast growing, it's a massive carbon sink. And so some people kind of approached us and said, well, you use equipment to harvest the hemp, then you transport, and you use factory equipment to make the blocks. Are they still carbon negative? Well, there was a study done. In fact, it still is, which is incredible. Okay, so this is a little kit that we developed. So what we've done here is our goal was basically to eliminate formaldehyde out of the construction completely. So we were not able to do that with the floor because you need structural plywood. The plywood that doesn't have formaldehyde out there is not structural. You cannot use it to act as a membrane or a diaphragm of the floor, basically part of the structural assembly. But what we did was we eliminated plywood out of the wall. We used cross bracing, and we use 3 forms of insulation here. So block on one side of the stud, then hemp bat on the inside, and then that Styco wood fiber board on exterior, and we use cedar facade on exterior. We're also using timber frame here, which also has excellent properties of thermal mass. So it also absorbs the heat and releases it. And we do use plywood on inside there, but that plywood doesn't have formaldehyde. So our goal basically was to completely remove anything off-gassing in the structure and then show that it is possible to do that. We also introduced this rain facade, which is very unusual in North America, but very kind of popular in Europe. And what that means is that you can see the Styco board through the facade. But because the water can go in and out and the air goes in and out, it actually dries out the wood. And it doesn't allow it to rot. It's also it's a cedar that was finished with oil. Okay, this is just a little video. I don't think it's playing. I need to press something. Do what? Oh, there's a button there. Oh, okay. This is just an example of how something like this can be assembled and very quickly. So it took us 5 days to do that. So everything is pre-cut at a factory. So there's almost no waste. Our waste was tiny little cardboard box. The blocks did take a little bit longer, so it was another week. Okay. So that was just an example of how to lay the blocks. Very easy and straightforward. Anybody wants to use blocks in your home, that's how you do it. Okay, anyway, so that brings me to how do we prove the carbon aspect of it. There's a guy by name Chris Magwood. He has been a leader in hemp space for a very long time, and so he pioneered this beam calculator. And what it does is it's a great tool to design a building if your goal is to lower the carbon. And so what we can see there is that it turned out our project was not carbon negative or zero carbon. It actually does contribute to carbon pollution a little bit, but it's very low comparing to others. And what did it really was hempcrete, hempbed, and okay, and some other aspects, basically. What hurt us in this process actually is glazing, surprisingly, not surprisingly, but because we use wide opening there, it kind of added a lot of carbon to that. And steel roofing, which is great in many other ways. You can recycle it, it's like long-lived, it's very low maintenance, it's a great product, reflects your sunlight, so lowers your energy in the house, energy consumption, but it actually emits a lot of carbon during the process. So this is a great calculator for carbon emissions, but it kind of doesn't look at other things. So we thought steel roofing was one of the best, but this doesn't think so. Anyway, and so I replaced some products with the traditional products in the same assembly. And so instead of the wood board on exterior, it's the typical foam and fiberglass and all that. And you can see that now the carbon emissions are 6,000 tons or 6 tons. And then before it was 900. So it's definitely a viable option. And if we're going to build a city size of New York every 30 days in the world, this is one of the ways we can affect carbon emissions. This is another project we worked. So beautifully executed by the gentleman right there, yeah, from American. So he sprayed up against the blocks. The project was managed by Hempstone, this other company in New England, designed by Kaya. Her company is for some reason some letters are missing. I apologize. I don't know why, but You Are the City is her company. She's out in New York. Beautiful little project. And so her goal, so these are a couple of photos that show basically the final result, coat of plaster, our blocks, and then on the right is basically block on interior and spray on the exterior. This is the first application of its kind in the United States, and that's how a lot of them are done in Europe. So this was a great project for us to see if it would work. And Kaya, the architect, also did this carbon count with a calculator. And basically she determined that so it stores as much as 165 tree seedlings grown for 10 years. Actually, I forgot to mention that our tiny little structure basically stored as much as 350 trees grown in 1 year. It's amazing. It's huge. And here I just copied from her research. The difference between our project and using spray foam is 52 metric tons of CO2, an amount equivalent to 62 acres of forest sequesters in 1 year, or 135,000 miles driven in a passenger vehicle. That is crazy numbers. And especially because if we realize that this is possible and it's a viable form of construction, then that makes a huge difference for all of us in the future. I don't know what's going on. This was fine before I left. But what this is I'll decode it for you. So there is a company in Canada that used to make structural block. It was called Just Biofiber. So for us, when we started in this industry, we thought, okay, can we test it? Will it pass all the tests? Well, they've done it, and they made this block. The company, for many reasons, did not take off, but the blocks passed every single ASTM test they needed to market in North America. So it is definitely a real product out there. Okay. we're encouraged by the country-wide sustainability goals across the country, different states, different requirements, but it's only going to get more stringent. So we believe that there is definitely a lot of potential to have some kind of incentives and make it more possible in other states. Okay, what else hemp gives us? Hemp gives us an ability to create a circular economy. Basically, Michael mentioned the last missing piece is processing. I would like to add to that manufacturing is also. So we can make the block, we can install it, we can design project with it, but we don't have a facility that would make it easy and affordable to build it. So we make them at the factory in Reading, but it's not very, we're retrofitting the equipment and it's not very efficient. So what we're doing now is we have a team of engineers and they're designing a better equipment that works with biomaterials that will make not just our block, but just biofiber and other products. Yeah, I forgot to mention something. One thing in the calculator, carbon calculator, it's very important to know that even though we all think that trees absorb carbon, sequester carbon as they grow, it is actually not counted towards the carbon sequestration in the calculator, which I was very disappointed about because we used timber frame, which is beefed up frame, but he didn't use any of those, any of the carbon that was sequestered. Why? Can anybody tell me why? Any thoughts in the audience? Okay, that was a surprise to me too. So when they mill that timber, the sawdust that's remaining, they throw it in the fire. So to keep the fire going in the kiln. And so all that is emitted back into the atmosphere. So I don't know if you've heard about Prometheus Materials, but they developed a structural concrete block that's very low carbon, basically 5% of concrete block. And so that block, so if we modify the structure and we use something low carbon and we combine it with hempcrete, then we're golden in terms of the carbon. Then us as a society, we are doing the best we can. And so the circular economy is also possible. It can help us create a more sustainable local supply chain, where this is a live example. It says Reading, where we are. We're right outside of Reading. So Coexist is right there. So this is partly kind of like imaginary map because we're not working with local farmers yet. But this is all farmland. We can grow our hemp there. We can have a processing center there. We manufacture our blocks here. Then we have a furniture maker who makes furniture out of hempcrete here. We use solar panels sprinkled across, installed for a sustainable factory. And then we build those structures, which are pre-built at a factory. We can build them here as well. So this is a circular economy idea that we presented at the Venice Biennale, actually. And we believe that it is possible to do across the country if we have those block making mini factories sprinkled across the country. So that is the idea. Basically, what we are doing now is we are developing. Oh yeah, and so basically on this map here, it's us right there, very close to all the important centers, also at the crossroad of some major roads, easy delivery to the big cities. We believe that this is the future, where you're located just outside of major areas, direct with the roads. And so within 90 miles, we can deliver, or within, well, 90 miles is ideal, but maybe we can expand the circle. We can have that circular economy within that 90 mile. But the beauty of this system is that we can replicate it across the country. And that is basically our goal. We're developing this mini factory that we will lease or sell across the country to make it possible for local sustainable economic development and product development and healthier construction. And let's see, just to quote Michael again, people, planet, and let's see, and profit. So people can make a living. Okay, and so that's the idea. Oh yeah, so basically this is a factory. Very quickly, it's just like, it's basic. It's a very basic layout of what we're doing right now. It is patent pending, and so we were advised not to share more. But the idea is that it will be fully solar electrified, and yeah, and basically that's what we're doing right now. And that's it. We believe that if we build well, we live well, and healthy buildings equal healthy people. Thank you.